Hello and welcome to Golden Droplets, a series of webinars aimed to close the gap between the industry and the academy. In today's episode number 40, we're going to be talking about a technique. It's called the Paleogeological reconstruction. It's an excellent exploration tool that will help you understand the evolution of your region and also to determine which type of deposit you can find. So, once again, Golden Droplets, episode number 40. Enjoy. So, what is paleogeological reconstruction? As many exploration tools, this is a very simple one that requires only thinking. For example, if you see a sandstone, you ask yourself, well, in which conditions this rock formed? So apparently it must be a lake or a sea or even a river. Okay, now that sandstone has some corals. Okay, that's narrowed down. Now we're talking about the sea, probably not deeper than 20-25 meters, which is the maximum depth for corals to evolve. Now, let's say that you see a gneiss. What is this? Well, in order to get the gneiss, we previously need to have some kind of big basin, like a marine basin, filled with clayish sediment, and all that has been compressed by regional metamorphism. So that's how you get the gneiss. Now, if you know that this gneiss is, for example, Jurassic in age, then you know that the conditions, this marine basin with sediments, must have been there before the compression. So pre-Jurassic times, there was some kind of marine basin filled with clay that was compressed due to regional metamorphism. Let's say that you see basalt. Okay, what type of basalt is? It's a pahoahoa, a is a pillow basalt. That we know that basalts are lava, they are coming from volcanoes, but these different types of basalt will tell you the conditions under which the eruption happened. For example, you have pillow basalts, well, you know that you are under water. You see, for example, a quartz vein. Okay, quartz vein, you know that is an hydrothermal product. You know that you need to have some fracture or some space. You need to know that there must be some kind of source of the hydrothermal fluid, like a granite or some kind of batholite. That is the source, and that provokes the circulation of these high silica waters that at the end form the quartz vein. So you need to play with three concepts at the same time. First, what are you seeing? What are the conditions to form this rock that you're seeing now? And what age is the rock? And what kind of mineralization you can find under these conditions? So this is why this paleogeological reconstruction is so useful, because when you reconstruct your region, you will figure out very quickly what kind of deposit could form under these conditions. And this will change for every age. So to do this, you start with a good stratigraphic column, and you start from the bottom to the top, explaining all the geology that you see. You see a marble, okay, this was a limestone, the limestone formed in a marine environment of normal salinity, and then it was metamorphosed. Why? There may have been an orogeny, or there may have been some dynamic metamorphism. Okay, but what kind of mineralization you can find here? I'm not talking only about metallic mineralization. The marble itself is a product that can be used in the construction, even in semi-precious stones category. And you continue doing this process layer by layer. And even more important, if you see an hiatus, like a missing stratigraphic age, that is as important as the presence of a rock there, because it means that during that period, something happened that no deposit was formed. It may have been a regression of the sea or any other product. It may have been eroded. So you need to explain all these things and create a model using cartoons. And after this, I'm going to show you an example of a paleogeological reconstruction of an area in Armenia, where I worked some years ago, which have a beautiful, it is a beautiful example of how to explain the different geology, the hiatus, the different type of mineralization that you can find, etc., etc., etc. The PowerPoint that I'm going to be showing later, you can download it from a site from Mendeley Data. I will put a link in the video, so you can download that PowerPoint and study it. So you use it as a template and try to start right now with your area. Take the geological map, it always comes with a stratigraphic column, and try to explain all the steps, all the different ages coming from the bottom to the top, and create your first paleogeological reconstruction. I guarantee you that you will be very satisfied with the results. You will have a much better understanding of the geology, of the evolution of your area, and of the potential ore deposit, metallic and non-metallic, or even oil and gas, that you may find in your area. So let's take a look at the PowerPoint. So let's see an example of a paleogeological reconstruction of a region of Armenia, where I worked several years ago. You can download this PowerPoint presentation from this link here. This is the DOI for this presentation. So you can use it later as a template to process your own data. As I mentioned before, the first step is to get or to create a good stratigraphical column of your area. And this is one that I generate myself based on existing data and new results from the mapping and the drilling that we're doing at the region. So our oldest rocks were of the Silurian age. And the story here starts with the deposition of limestone over a cross of gneiss and other metamorphic rocks from the basement. So you have here a cartoon for mentioning, the basin, the seawater, the limestone, and the gneiss, which is the base of this thing. You could even have started before saying that in pre-Silurian time, there was the same marine basin, but it was filled with sediments like clayish material that were metamorphosed to form this gneiss. The second step was the Middle Devonian, where we have the formation of the limestone of the Getty Formation. Very simple, quiet time. The Karoo Ice Age covered the region from the Carboniferous to the Triassic. So that is why we have that big hiatus in the stratigraphic column. And of course, there is no ore potential in this period of time. Then there was the retraction of the ice cap during the Permian period that allowed the formation of the limestones of the Darauirit Formation. Another hiatus probably associated to the same Karoo Ice Age, that the Ice Age went through several retractions and protractions. So we have this second hiatus here. Now, we got to the Upper Jurassic to Lower Cretaceous period. That was a very active one, with intrusion of mafic and felsic magmas and the beginning of the volcanic activity. both underwater and above. Lava flows could have destroyed previously formed skarn or covered them. Besides the disseminated mineralization in the granitoids and a newly formed stockwork zone, we may have siderophilic type of mineralization associated with the gabbros, like nickel, cobalt, chrome, plus gold, copper, gold associated to red bed basalt, and both VMS and SEDEX type of mineralization. All this type of mineralization are shown here where they could have been formed. A relatively calmer time came with the Upper Cretaceous, no formation of new sediments of any importance. Then we have the regression of the water sea level as a prelude of the coming new ice age, which happened during the Paleocene hiatus or the modern ice age. It provoked an hiatus in the stratigraphic column during the Paleocene. The effect of the moving mass of ice could have destroyed previously existing deposits, but also uncovered deeper buried one. This is a very important thing to keep in mind, the effect of this ice sheet. Next, in the lower Eocene, during the Ypresian Eocene, we have the reactivation of the magmatic event, represented by a new intrusion or pulse of felsic magma and their corresponding tuff, we can see here. Apart from the disseminated mineralization with the granitoid, it is expected a significant increase in the activity of the stockwork zone that could have contributed to the deposition of new mineralization or the remobilization of previous existing one. There is a significant regression of the seawater level during the Pre-Devonian Eocene period, probably again related to the upcoming climate change of the Pleistocene. You can see here the regression of the sea level. And finally, the geological evolution of the region ends with eruptions of basalt andesitic lava, indicating a deeper magmatic source, but barren ones. They do not carry mineralization. So right here in this cartoon, we have the evolution of all our area with the different type of mineral deposit that we can find and where we can find it. So for example, you can search for SEDEX, uncovered SEDEX in a region like this, by geochemistry, geophysics. You always have the nickel, cobalt, chrome, gold potential of the ultramafic rocks, and probably VMS related to the volcanic activity, the zone of the stockwork with copper gold mineralization, and the porphyries with copper gold silver mineralization. So this is an example of how to use the paleogeological reconstruction in order to better understand the geology of your area and the ore potential. I hope this technique will be very useful for you. As I mentioned before, you can download this PowerPoint presentation and use it as a template to explore your own targets. Until next time, have a great day.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.